we basically are trying to implement stack. This is the program that I wrote. Here you can see there is an array. There is a top variable which has the basic size of this array. The size is basically 5, but this is 4 because you know the array starts from 0, right? That's why I have written it 4, because 0, 1, 2, 3, 4, total of it makes total of 5, right? So I need to keep it 4. Now there is one functionality that is empty. There is one peek. There's a pop operation, there's a push operation, there's a display operation, and I ran them just randomly. Well, first I've displayed it, then I've peeked the top of the stack, and then popped one element from the top of the stack, and then peeked at the stack, and then displayed. I'll show you guys how it's executed, but this is basically display I is equal to top, right? From top to 0, print all the elements of the stack. That's what display does. Empty. If top is equal to -1, then stack will be empty. You know that there are 5 elements, right? So it's 4, 3. I mean, its index is 4, 3, 2, 1, and 0. And if it's less than 0, then that means there is nothing in the stack. Stack is actually empty. And if top is not equal to 1, then that means stack is not empty. Stack has something in it. If top is equal to -1, then stack is empty. And then now here, this is pop operation. I just what I do is I reduce the value of top by 1, or rather decrement the value of top by 1, and then we just say that this element top has been removed. Well, since I have reduced, why am I saying reduced? It's not reduced, it's decremented. That is proper word. So once we've decremented top, we just write here top plus 1, because top is less than what top was, right? 1 less than. So we just add 1, and we just show them that this element has been removed. Now push operation. We increment the value of top. We'll have to write a condition here that I mean, if stack, we will check if stack is full or not. If it is full, then we will say that there is no more space left and we cannot push into the array. And if it has space actually, then we increment the top value. Then we ask them to push some value, so they will enter something, some number, and that will be pushed into the array, on top of the array, or rather on top of the stack, right? And after that, we'll just tell them that this particular element has been pushed on top of the stack. We could just write here peek, and it will display them, but whatever, right? I have written this, and that works. So if it works, then don't touch it. We'll make some changes into it, I think, right? So it's working. Wait a second, let me just let me go over here and click undo. Now let's just leave it on that display, and what we'll do is save. Control plus S is for save, then GCC O, and then name of the program. I mean, whatever name you want to give it to this executable, and then the name of the program, that is main.c with the extension, right? And now that it has been, it's not giving errors. That means that it has been what should I call it, compiled. Now let's just write stack and run this program, and you can see that 5 is on top of the stack. 5 has been removed, and then what is left is 4, 3, 2, 1. Right? Initially it was 5, 4, 3, 2, 1, and then 5 was on top of the stack, right? Then 5 was removed. First we displayed, so 5, 4, 3, 2, 1. Then we peeked, and that's showed that 5 is on top of the stack. Then we popped an element, so 5 was popped from the top of the stack, and then we printed display. So it showed 4, 3, 2, 1 since 5 was removed from the stack. So you can see that it is working properly, but our users are not going to write these things inside of here, right? They'll just want to see how it executes. So what we'll do is write, let's see, int yes is equal to 0, rather 1, do function. Now here, let's see, what we will do is, let's write printf, and 1 should be display /n. Why not write it in the same line? Yeah, I think that is a better way. So push /n 3 pop /n 4 peek /n 5 is, or rather isn't, should be like this, is empty. These are the operations, and then /n. Pretty good. Now what do we do? Now we'll tell them to select something, right, from this. So let's see, int cell is equal to let's say initially it's nothing, right? Initially it's nothing. Printf what, rather we have to have this these, right? What operation do you want? What's going on with my typing? What operation do you want to perform? Let's select this and scanf to get the input %d, and then we need to have ampersand and cell. Now let's see, we'll use switch statement, right? Switch will take cell as input. Case 1 should be display break. Case 2 should be push break. Case 3 should be pop break. Case 4 should be let's see, display push pop peak break. Not this, right? Case 5 should be is empty break. Default should be invalid selection /n. Please select correct option /n, and then that's about it, right? Default is the last one, so there is no need to give break. Let me see one more thing. Oh yeah, do you, or rather we'll have to write a print statement, right? Do you want to continue? Wait a second, we are not going to do this inside of select, right? Yeah, we are not doing this within a select statement. Yeah, before while. Oh yeah, so there it is, right? So this is inside of do loop, outside of the select statement. So here we are going to check or ask printf, do you want to continue doing operations on scanf %d? Yes, right? Yes. And if it is yes, then while yes is equal to 1, right? If it is equal to 1, then it will execute. If it's not, then it will not. Control plus S. Now since we have saved it, we are going to check. So let's if it executes perfectly, then fine. If it doesn't, then it doesn't. Let's see. GCC o stack main.c. Perfect, no error. I thought there would be some, but there is none, which is perfect. Now just run the program stack. Now there you go. It's giving us options: display, push, pop, peak is empty. We are going to click on 5. It says stack is not empty. Do you want to continue doing operations? 1 is for yes, or rather any number you write is for yes except 0. If you enter 0, then the program will stop executing. So we write 0 and then you can see that we are out of the loop. We are not doing any operations. The program has stopped execution. Now we'll write stack again. By the way, I pressed the upward key, the up arrow button to sort of get the last command that I wrote. So the last command that I wrote was stack. So now we can just do this. And let's display push or peak. What do you want to do? Let's do fourth operation, the peak operation. And you can see 5 is on top of the stack. So they are telling us. Let me see. There you go. So the top of the stack is the last element, right? Last in, first out is the thing in stack, right? So the 5 is on top of the stack. So you can see 5 is on top of the stack. That was a peak operation. Peak operation shows you the first, the topmost element on the stack. Now do you want to continue operations? Yes. So perfect. It's giving us options again. Now what do you want to do? I want to do pop. 5 has been removed. Yes, I want to continue. So 1 as a command for redoing operations. Now 4. Let's see, peak. So 5 was removed and now 4 is on top of the stack. So let's do one more time. Pop. 4 has been removed. Yes, I want to continue. Now I want to see the top of the stack, that is 4. Now 3 is on top of the stack. So you can see that 4 and this 5 was first removed from top of the stack, then 4 was removed from top of the stack. Now top of the stack is 3, so you can see 3 is the top of the stack. Now do you want to continue doing operations? Yes. What do you want to do? So I want to display the array, the stack. So you can see 3 is on top of the stack, beneath it is 2, and then there's 1. Do you want to continue? Yes. Let's ask if it is empty. Do you want to, what operation do you want to perform? So I want to check if it's empty. So stack is not empty. Do you want to continue doing operations? Yes. Let's see, peak operation, right? We have already seen that it's top of the stack, so let's do push operation, right? So 2 is for push. So what do you want to push? I want to push 100 on top of the stack. Now you can see that 100 has been pushed on the stack. Now you can see 100 is on top of the stack. So as I said, the last element that you add is going to be on top of the stack. That is how it works in LIFO, right? It is LIFO, last in, first out. So last in will be the top of the stack, and it will be the first element to be removed if you want to remove something from the stack. So let's add more elements. 2 is, do you want to continue some operation, doing operations? Oh, yeah, anything. I was wrong actually. Since I have, you can see here that I have clearly written. Where is it? If it is equal to 1, then the program will run. Anything else will stop the program or terminate the program. So well, basically it's working properly, right? It's working properly. Every single function, all 5 of the functions that I have written are working properly. And since I used array this time, next time around I will like use linked list. By the way, I have already created a video on like creating stack using linked list, so be sure to check that out. That's about it for this video.